So the more content I shot and edited in that LinuxCNC and HAL tutorial series of mine, the more I realized we really do need to cover a few Linux basics first. Nothing crazy, just some notes and some pointers that'll make it easier for you to work on a Linux system and to follow along with the files in my HAL tutorial. And hopefully within about half an hour, we'll have covered enough, you can hit the ground running and pass yourself off as a software engineer. So, for us to start off, what the fuck is Linux anyway? Right? You've definitely heard of it. You've probably heard of a bunch of kinds of it. You know, Ubuntu, Mint, Debian, Fedora. There's a million different kinds of Linux. So what gives? Well, what makes Linux Linux is something called the kernel. That's the program that runs all of your other programs and manages your hardware. So when a program wants to open a file, it asks the kernel to ask your hard drive for the data, and then it passes that data along. Windows and Mac also have kernels of their own, but those ones are proprietary, and you only get them when you buy a computer that comes with the full-blown operating system. So that includes the kernel, whether it's a Windows one or the Mac one, as well as all the default programs and the desktop interface and all that stuff that comes bundled to make a full-blown OS. Linux, on the other hand, is just the kernel. You need to bundle it with other software in order to get an OS. So all the different variants of Linux are just different bundles of software with the kernel. And because it's an open source thing, people can pack it up with whatever they want and then ship that as Debian, Ubuntu, Fedora, CentOS, Gentoo, Arch, all the different Linuxes. They can do that because the Linux kernel is open source. And really, all these variants, they are mostly the same. Okay, not much changes between them. The look and feel is a bit different, but for the most part, a lot of the programs that come installed in them are the same, and a lot of the things that the way they work are the same. It's really just Linux. Now, LinuxCNC is based on one called Debian, and that's also what Ubuntu and Mint are based on. That's important to know because if you want to find instructions for how to do something on LinuxCNC, those ones are a lot more popular, so you can search for Debian, Ubuntu, whatever, and the instructions you find on them will usually work the same on LinuxCNC. The only caveat to that is that LinuxCNC is based on a very old Debian, Debian 7, also known as Debian Wheezy. And that one is very old, like from 2013 or so about 7 years old by now. So if you want instructions, you want to look for either Debian 7 or Ubuntu 12, 13, and 14. And those are from roughly the same time range, and things will work similarly on those and on LinuxCNC. Now, why does LinuxCNC use such an old Debian? That's because it comes with a special kernel that includes the RTIA extensions. That's the real-time application interface. It's basically the thing that lets you run your CNC gizmos in effectively real time. Now, if you've looked at like Windows CNC setups, they always come with dedicated controller boxes that you plug in via USB. And that's because Windows does not have a real-time interface on its kernel. So that USB connection to your controller box is buffered. That is not real time. But the controller box itself can work in real time to send signals to your stepper drivers. So your computer and your controller talk to each other, and the controller talks with like Mach, the CNC software on Windows, and then it gets the commands that it's going to send to the stepper drivers when the time is ready as it operates in real time. Now Linux, you don't need that separate controller because the RTIA kernel can do it for you. And they can have that special kernel because, again, Linux is free and open source. So it's just readily available for you to make whatever extra features on it that you want. Whereas Windows, you can't. The problem with that is keeping the special kernel updated is a bitch and a half. So LinuxCNC has kind of lagged behind a bit. And that comes into play where some of the software you're going to find is a little bit old and kind of outdated, right? More importantly, things like your web browser are going to be woefully insecure by this point. Okay, you can't take a browser from 7 years ago and safely put it online nowadays. There's just too many vulnerabilities been discovered in things. You really don't want to do that. Okay, so you either want to keep your CNC machine offline entirely, or at the very least, please don't go downloading Russian porn on your CNC machine. Otherwise, your lathe is going to get malware, and nobody wants that, right? Now let's go to the command line, because that's where you can work most efficiently on a Linux system. They have the graphical environment here you can use, and that's fine, but the command line really is a powerful tool, and like any tool, once you learn how to use it, it really does improve your overall workflow. So we hit this icon down here, and then up pops a command line terminal. You might also hear this called bash. That's the proper name for the program that runs your commands, but command line terminal bash, Basically all the same thing. Once you have it open, you can do things like pwd, get the path of your current working directory. We see right now I'm in my home directory. You can ls to list the things that are in your directory. cd will let you change where you are. And you can ls things that are in here. Let's see, cat will spit out a file. Yes, cat is a funny name. There's a reason for it. We won't get into that one. Lots of Linux history in some of these programs. But anyway, cat will spit a file out. CP will copy a file. So you can copy readme to readme.copy, just like that. And now we can ls and see there's indeed a copy here. And it has all the same content. So then we can move a file like this and say ... to refer to the directory above where we are right now. So that'll move readme back to my home, and we can cd there, take a look, and sure enough, the readme has moved similarly. Now as a bonus, you can also do cd dash, and that will let you go back and forth between two directories quickly. So if I cd'd here, and I cd down to this other random directory I know is there, and cd dash again, I can swap back and forth between the two really quickly. If I don't pass an argument at all, then just plain cd takes you back home, right? Now, all these commands I know do kind of look like mumbo jumbo, but trust me, eventually you get the hang of them and it makes working very, very fast. For the time being, I just say go online and get a cheat sheet or two, print them out, put them by your machine, and eventually you will get the hang of it. So now carrying on, we can remove a file with rm. So if you do something like rm and then readme, there's a trick you can do as well, that once you type a few letters of it, you hit tab and it'll tab complete out the rest. So if you've been listening to me type, you probably noticed I don't type nearly as many keystrokes as things that appear on the screen. That's because tab complete is such a time saver. It lets you really get point to files much more quickly. Now let's say we want to specify this a different way. You can hit Control C to cancel, and then do it again. And this time I'm going to do it with a glob. So this glob is a pattern matching type thing. That star will basically match anything in a file name. So anything now ending in copy will be deleted with that command. And sure enough, that's gone now. So if you have a directory full of old G-code files you want to wipe away, then rm star.ngc will take away all those old G-code files. Just be careful, because it will take away all the files that match. With that kind of power, you gotta be careful and make sure you really are doing what you want to do. Now we've typed a few commands. If we want to go back through the history of our commands, we can use Control R and then do like CD, and then hit Control R more, and it will scroll back through the CD commands we did. Or hit Control T now, and it'll scroll back forward to those commands. So that's also kind of handy. Or if we just type history, we'll actually spit out the full-blown history of everything we've done. So that's another convenient one. Making it even better, we can do something like this, history pipe less. Now, what this is doing is it's using the, let's see, how do I describe this? Less is a program that lets you scroll through a file, right, or some content, not need to look at all of it at once, right? So you can scroll through and look at a little bit of it at a time, less, right, not the entire thing. So the history spits out your whole history, and less lets you scroll through it. And the little pipe character here, that straight down slash, takes the output from history and then pipes it directly into less. So we do this, and now we've got our history here, and we can scroll up and down using some keys. Either scroll down slower, or hit some other shortcuts to scroll down faster, and it lets you go through and navigate very quickly. And then once you've gone through that, you can hit Q, and that's how you quit out of less. We can upgrade those history settings too, so it'll actually save every command you've done for all time with timestamps, not simply the numbers we've had here. Now I haven't actually done that on this machine, but it is definitely a useful thing to do, because that way you can go back like months and months in the past and find that magic command you did to do some process that you have to do all again now suddenly months and months later. And saving all of your bash history takes maybe a few megabytes of space in your hard drive. And when you have hundreds and hundreds of gigabytes, it's really not much space at all. It definitely is worth it. I haven't done it on this machine yet, but eventually I will get around to putting notes on how to do things like that in the files for my HAL tutorial. So Over on GitHub, I've got this project for places I just dump files related to my YouTube videos, and this LinuxCNC directory has everything for that. And in the MIS directory here, I will eventually be dumping more stuff we talked about in this video. Obviously, I haven't done it yet because I'm talking about it right now, but I will get around to that. Now let's talk about everybody's favorite tool, grep. Okay, this is the one that will really save your ass when you're going through all your HAL files, trying to find where they're defined or used or hooked up on net or anything like that. Okay, grep lets you search through files with regular expressions. We don't need to worry about too much about what regexes are right now. Just know they're a search term and they have a lot more power than I'm going to show you in these few examples here. But let's say I head to my HAL directory. So cd, LinuxCNC, configs, HAL tutorial. Okay, and I do a, let's see, grep-i-r-c5 spindle on pipe to less. What this will do is it will search through, let's see, case insensitive recursively, so every file from this directory onward, and giving us 5 lines of context wherever the search term spindle on appears, and then it will pipe it over to less. So there we go. And in fact, if I quit this and I go back and rerun the command by hitting up on the key arrows, I can come back and edit it and add a color equals always, and color equals always, and then make sure less processes the color with its flags. And now, when it processes that for us, we get coloring to kind of make it easier to read the information. So we can see over here in 30-thc.hal, I hooked up the spindle on signal to thcud on the torch on signal. And then you can see other places where I used it across 2 other files. So it really makes it very quick to find everywhere you use something on your on your configuration files. And that's great and all, but where exactly do these flags come from, right? I just pulled off the -IRC and like color equals always, and then the -SR unless. Like, how do you learn what these things are? Well, that is all in the man pages, and that's man for manual, not for patriarchy. So just calm the fuck down, right? Man pages. Okay. So if you go man grep, then you'll get the manual for grep. And this one has basically every single option and a whole bunch of examples as well on how to use this tool. Likewise, you have manrm, mancd, like basically every command line tool has a man page teaching you how to use it. You might also notice that this scrolling thing here is kind of a lot like less, because this is actually run by less. And there's another cool feature of that I have not mentioned yet, which is that you can grep while you're in less. So if we're in here and we hit / and we type a search phrase like recurse and then hit enter, we can use little n to scroll forward through those finds and then big N to scroll backwards. And we'll see, it makes it highlight all the matches, and that this one here is that flag for recursing. So either -big R, -little r, or double dash recursive, any of those flags are the same thing as far as grep is concerned. So this is a blazingly fast way to scour through the documentation and find that nugget you need when you're putting together your HAL or just generally working on a Linux machine. It makes it very easy to learn once you know how to find information. Okay, don't bother trying to memorize all this shit. Okay, memorize how to find the shit, and that is a much more useful skill to have. Now, speaking of finding things, there's another great tool called locate. It helps you find files. So grep will search the text within a file. Locate will help you search just based on the file name. So it goes across your entire computer, and it already has an index of every file on your computer that it updates every day. So if we do like a locate document PDF, okay, boom. So in the fraction of a second that took, it actually highlighted that documentation PDF for LinuxCNC that you usually get to by going through the menus here. So this document, that 700-page LinuxCNC manual, is located right here on our computer, and that was only a moment to search and find. So let's say we go to that directory and see what else is included with it. So user share doc, LinuxCNC, and then we can see what else is included here. Now that we're here, what if you wanted to browse this with a regular old directory browser, the way you would in any other computer? Well, there is a folder browser included with Debian called Thunar. So you can actually kick that off from the command line, and then we have, a typical thing you click around in, and you can look at files that way, and that works just fine. Now let's head back to the configuration directory and try editing some things. So you can cd dash and go all the way back from that last place we were back to where we were again, and then try editing some of these HAL files. Personally, I like using a program called Vim. That's kind of like less for editing. It's like less lets you view a file. Vim is similar, lets you edit the file, and has a lot of other features, like a lot. So that's really a program that software developers use pretty heavily. But you might have an easier time working with a simpler program. So I generally would recommend Gedit is probably the one you'd have more success with. So Gedit is a lot like Notepad on Windows, only it's for Linux, and it has some extra features like tabs and things, so you can open multiple files at once. So for example, this is another graphical tool. You can still load it from the command line by doing gedit star.hal, and then that will open up every HAL file I have in here on a separate tab, so you can click around and look through everything we got. Now you might notice that launching Gedit then freezes the terminal, right? Like we did not get another prompt for new command after this. And that's because the terminal is waiting for Gedit to finish before it moves on to take the next command. So we're going to hit Control-C to cancel and kill Gedit. And if we launch it again, hit up on the key arrows to reload that last command, and then hit an ampersand at the end. This is the shorthand for backgrounding a process. So when you run Gedit then, we still keep the terminal that we can use, and then Gedit runs separately. So we can still do like ls and keep using the terminal even while Gedit stays open. Nifty, right? Now, Gedit doesn't come installed by default. We do have to install it separately. Linux isn't like Windows though, okay? You don't go to cnet.com and download a program that's chock full of adware. Linux is more like Mac, like where you have an app store and you download verified programs. The difference is on Linux, the app store is on the command line because of course, this is Linux. So the tool you use for that in, Debian, Ubuntu, Mint, and LinuxCNC is a tool called apt-get. So we look man apt-get, and here's the man page for this tool. But of course, we have another snafu, right? Because LinuxCNC is very far out of date. So we need to tell apt-get to look somewhere else for the programs because the place it usually looks has actually been deprecated and is no longer online. So there's a configuration file we can look to down in etc.apt, and we look at sources.list. So this is what tells apt where to look for software. And we used to have all these sources down here, which are now commented out. And these are things that look at like debian.net and debian.org and look for files saved on there. Those have all since been moved to archive.debian.org. So this is another change you'll have to make on your Linux system if you want to install more software, just because LinuxCNC is so far out of date. The software you get here will also be older versions of software. Like they won't have the newest version to Gedit, but it will have a newer version than the no version that comes pre-installed. Okay, so again, this is one change you'll have to make, and I'll have a blurb about this over on the project here on GitHub. All right, so once we've added that to the sources that apt looks in, we can run sudo apt-get update, and that tells apt to look there for the software in that location on archive.debian.org. So basically, go down there and it pulls down lists of all the software available. And there's also a few sources linked up for linuxcnc.org because obviously we're working on LinuxCNC, Wheezy, with the RTIA extensions on LinuxCNC 2.7, right? Now we want to run, let's see, apt-get install to install Gedit. So one thing I want to point out here, before I move on, is this little sudo bit, right? What exactly is that? That's a command that means do this as a super user. So sudo super user do. Okay, now the super user on Linux is basically your administrator account. So it's either called the admin or super user or root. They're all synonyms for the same thing. And that's the account that can modify more of the important system files. So if you do an apt-get update without the sudo, it's going to complain at you and say that you don't have permissions to touch those files because you are not acting as the admin account. You are acting as your personal account. So you have to explicitly use sudo to touch system things. And that's a good thing because it keeps you from mistakenly like botching up a whole bunch of system files just with an errant command when you're working on the command line. So you should usually try to operate as your regular user and only use sudo in the root account for when you need to do something that requires system-wide access. So we do that to update the list of software, and then sudo apt-get install. We can do ged, hit tab, and that will give us all the options. And we see get it is definitely on there, so we'll get it, and we will get it. Well, I've already gotten it, but that is how you would install it, and then you can run it just like I showed before. Not that bad. There's a few other tools you're going to want. Git and gitk definitely come to mind. But again, I will take a whole list of those and chuck that up on GitHub over here. And you can get those, install them whenever you get around to it, to make it easier for you to follow along with the HAL tutorial series I'm putting together. And let's see, we are now done with this, so you can close this guy out. And another little trick is when you're working on the command line, you can hit Control-L to clear the screen. And now we'll head back and actually go back to our home directory, clear that, and move on to, I think let's cover a few basic parts about Git now, because again, I am using GitHub for storing all this code. So Git is a tool that software developers use for tracking source code, and it's probably the best thing you can use for keeping track of the updates on your LinuxCNC configurations. That way, when you inevitably fuck them up, you can always go back to a working configuration that you'd had before. So let's grab a local copy of my project here on GitHub. So, when you're here on GitHub, you can, obviously, poke around on here and browse it in the web browser, but it is a bit easier, in my opinion, and it's easier to copy files and things when you have a copy of them locally. So you copy that URL over here and go back to our box. Let's see, and we go to a place we can drop a copy of this off, and we git clone, Control-Shift-V to paste. It's a Shift-V to paste. Hit enter, and then it will download the project of mine in the history of every change that's happened on it to your local machine. So we see it here, and now we can poke around to your heart's content. Now, probably the best tool for looking around is one called gitk. So we'll launch that in the background with the ampersand. What was this? Oh, whoops, I typoed. Gitk with the ampersand. There we go. And this gives us a list of every commit I've made on the Git project. So click on this one here. It has a message that happened with the commit. Gives you the date that it happened. Gives you comments saying, which files changed. And if we scroll through here, we can see every change to every file, where it takes the things we removed, puts them in red, and things in green, puts them in things we added and puts them in green. And that goes for every commit we have in the sequence. So if you're ever wondering why a file is the way it is, gitk is a great way to browse through and just kind of see the whole history of the project. Then if you want to look at files from a certain point in the past history, you can use git checkout and refer to the commit either by using this here called your SHA-ID hash. This long bit of gibberish is a unique way to refer to this commit. Or for the commits that have tags on them, like this guy here, you can git checkout this tag. So go over here, and if we look at the files currently included in the LinuxCNC directory, you see we have all this stuff from when I finished doing the CNC HAL tutorial. So if I do a git checkout, and I check out the HAL tutorial part 1 now, and then I do a tree to spit out all the files in LinuxCNC now, we'll see it's changed back to what we had at the very, very start. So it gives you a checkout of everything at any point in the past history, which is really a powerful thing to have. Then to go back to the latest, you can always grab either the tag or the SHA hash of the most recent commit on the project. There's some other shorthands you can do too, but there's so many things you can learn about Git, and we're only going to touch on the very, very basics. So if I do a new Git checkout to pull out the HAL tutorial part 9, that'll bring us back to the very, very end where we were just a minute ago. Now, I already had a Git clone of this project over in my home directory. So if I cd back to home, take a look, I had a copy right here already. I just pulled another copy into temp just as an example, of how you do a Git clone. But I actually already had it here on hand. But the project of mine, it includes a lot more stuff than just the LinuxCNC files, right? If I spit that out a tree, scroll YouTube, there we go. We can see there's all the LinuxCNC stuff, and then there's some things about an air compressor video I did before, and files for the Arduino THC that I also did a video on before, and those are there as well. But I want to have my LinuxCNC access GUI use configurations from this LinuxCNC directory, right? But that GUI looks for it present in your home. So how exactly did I pull that off, right? Did I copy and paste the files from here back to my home directory? No, because there's better ways to do things on Linux, right? So you see here in my home, this LinuxCNC is in a light blue color, not the regular blue of all the other ones. Why is that? Well, that's because that is a symlink, right? A symbolic link, basically a shortcut in Linux. So this LinuxCNC actually points to swobro-youtube/LinuxCNC. And basically every program that tries to access the file in here will end up accessing the files that are in my Git repository. And it won't even be able to tell just because it will naturally follow the symbolic link. And you can make a link like that with the link command -symbolic, and then you'd say from swobro YouTube Linux CNC, and then to Linux CNC. Now obviously I've already done that, so can't do it twice. But that is how you would make that symbolic link, and that way you can have configurations stored even elsewhere on the computer and make your system think that the files are where it needs them to be for it to operate as expected. So if I even go into here now, like so, and take a poke around, it has all the same things that were in that directory in the Git repository, and they are literally the same files. If I touch and add some new file, that's here now, right? This is just an empty brand new file. And I go back to Swobro YouTube and look in the LinuxCNC subdirectory. There we go. Now there is the new file. It is literally the same directory. That is how transparent a symlink works. It's kind of a handy tool to have. And now let's work on a little example of Git and how you might use this for keeping track of your own LinuxCNC configurations. And I've shown you now how to use it to kind of browse around and poke and see the files that I've written, but how to use it to keep track of your own. So let's go to temp, and then we're going to git init a new Git repository. So let's say git test, let's find enough name for practice, and it'll make a directory for us that we can go into, and this will be the new base for our repository. Now in this case we're going to dump some test files in here, but in your case you'd make this the directory that have all of your LinuxCNC configurations. So you can do like a touch file A, make a file there, touch file B, make another file. If we do a git status, it shows us that these two files exist now, but have not yet been added to the Git repository. So let's do that. Git add both of these, and now git status will tell us that they have been added and they are primed to be committed, but they have not yet been saved to the Git repository. They're just ready to be added the next time we run git commit. So from here, if we let's say we change the file, we're doing like vim file A, and then we said here is some content in file A, and then we save that and check git status again. Now git status tells us the files exist and have been, the fact that they exist is ready to be committed, but the changes on file A since then are still out there waiting to be added. So if we do a git diff, it'll actually show us what those changes that are still out there are. And that is a change to file A saying, here's some content in file A. So if we add it again, then git status shows us that everything is now primed to be committed and staged for commit. And then git diff shows us there are no changes waiting to be committed. So we can do our first commit like so and give it a little message. Now you're going to want to typically give your commits a useful message, right? One that tells you what the changes are for. In this case, we're just testing, so it's not terribly crucial, but you know, when you're making changes to your LinuxCNC configurations, 6 months down the line, you're going to be wondering why the hell you made that change that you did, right? So do yourself a favor and leave yourself a useful message. So now we save that. And that is the first commit in our repository. It has now saved those files. They're still here. We can still spit out the content of that file. See, A has the same things, and file B is still empty as before. And we can do gitk to see the new record of this repository beginning to form. And we can also do another tool I haven't showed before. Git log is similar to gitk, just it works from the command line and gives you a browser usually similar to less when you have more history than what we show here. But the same idea, where it gives you the commit hash, tells you who did it, when they wrote it, what the message was, and what the changes on that file were. Now let's do a second commit, and I'll show you a few more features of Git. So say we're working on LinuxCNC, and we're making a bunch of these G-code files. So touch 1, NGC, touch 2, NGC. It's just a bunch of files that have G-code in them that we don't necessarily want to save, because G-code files are like, they're for jobs, but we're going to accumulate a lot of them over time, and unless it's one that is actually a job we run frequently, you might not want to keep around all those old files and all that clutter. So if we look now at our git status, we'll see that it is chock full of NGC files. Well, there's another thing in Git called the git ignore. If you have a file called .gitignore, and you can give it globs in here on types of files you want Git to ignore. So if I do one like star ngc and save that, now when I do git status, it'll show us that git ignore has not been added to the repo, but all the ngc files are ignored. They don't even appear. Now, how exactly do you see the fact that there is a git ignore file there? Well, ls, the list command, usually does not list files whose name begin with a dot, but ls-l, or sorry, -a, then lists all files, and you can see that there is indeed a git ignore in this directory here. That is what actually stores all the history for your Git repo. So now we're going to add the git ignore to this, and git add .gitignore. And say we want to add one of those NGC files just because it's important, right? So we have one. So that file does not appear in git status, right? But we can still add it if we do a git add --force. Force important.ngc, and that will be added to the history tracking in Git anyway. So now you can do git commit and say important ngc, ignore the rest of them. And now when you open up gitk again, we see that history continues to form even more, right? First one and the next commit. So if you just learn these few little things, this will have you as well off with Git as 95% of software engineers. I swear, okay, most software developers don't know shit about how to use Git. There's way, way, way more than this. But these few basic things, will still have you so much better off than trying to copy and paste files and name things like .backup and .v1 and .v2 and .v3 for all the different versions, okay? Git is a tool you wanna just use even a little bit, will help you out a lot, okay? So commit regularly. That way, when you inevitably fuck it up, you can always go back to something you had before, when the machine actually worked. And if you find you aren't good about doing those regular commits, there's actually another tool called cron that lets you set up jobs to run on a schedule. Scheduled time, cron, they're all kind of, synonyms there. So cron jobs, actually, they exist in, well, you've got a few of them already in your Etsy directory. And I'll leave some more notes about that on the project pages here. But basically, a cron job can run, say, every hour and just regularly commit the changes you make to your configuration, regardless of whether you want to do it personally yourself or not, and just save it automatically for you. That way, you never have anything that's too far out of being synced and backed up. As another failsafe too, you are always welcome to start your own GitHub project and put your files up there. Whether you make a private project that only you can see or a public one, just having a GitHub account where you put those files kind of gives you a separate place, where it's saved safely out of your shop, right? Because this CNC machine, like the computer running Linux, is in your workshop. So, there's a risk that one day you might drop like a vise on it by mistake and like crush the machine, right? Like I'd already shown in an earlier video, I mistakenly broke my Xbox controller just by dropping some plate in it. Same thing can happen to your computer. And it would kind of suck if you broke the computer and then lost all your configurations. So if you have a GitHub account, you can just push things there and save them. That way they're safe. So if you break the computer or just dies of its own from old age or whatever, you'll at least have that bit backed up, and it'll make it a little bit easier to get back to where you were. So for that, you make a GitHub account, you make a project, you add that location to your Git repository, back to where we were. So here we can see that I don't have any remote locations on this project right now because I made it here locally. But you could do like a git remote add, and then it'd be like some github.com/something URL, and you would add that to that, and you could do a git push, and that would chuck all of your things up there on Git or GitHub. Anyway, that should be enough to pique your interest. There is still tons more I'd like to cover. Things like VNC and SSH and having the beep command for when your computer starts up so you know when it's done booting, right? Tons of things you can add to it, and that I will put little blurbs about over on my project page. But for the time being, I think that should be enough, sending you down that rabbit hole. And let's get back to working with LinuxCNC and HAL.